Hello there and welcome to a brand new lesson. This is Hap Beyond Numbers, where we learn math the easy way. In this lesson, we are looking at linear equations with fractions. And here are the lesson objectives. Without much ado, let's quickly look into each and every one of them. So looking at all that we've done so far, you might think linear equations involving fractions might not be straightforward, but then it is actually very easy. The reason why you might think otherwise is just because of three reasons. First of all, because of the presence of fractions, you'd have to be eliminating all the denominators. Hence, it increases the number of steps you will need to completely solve the equation. Secondly, students forget to apply operations to everything, because right after eliminating the fraction, it affects everything in the numerator, but students ignore that. And then finally, when you ignore the denominator, everything changes, because every number in your equation is very, very important. Remember, from the balance method, we said if one term is added, subtracted, divided, or multiplied from one side of the equation, the other isn't done for the other side, it changes the whole equation. Hence, the easiest way to solve fractions is to remove the fraction first. Then we will use the normal method. This can be done by using the LCM method. So talking of the LCM method, it is very, very straightforward. If you have all your fractions displayed, you first of all identify all the denominators. You need to identify all the denominators, and then after which you now look for the LCM of the denominators. After finding the LCM of all the denominators, you multiply each and every term by this LCM. We do what? We multiply. With that, you can now solve for the resulting linear equation. With respect to that, let's take some few examples and see how best we can go about them. So with our first example here, it says we have to solve x over 3 equals 4. What value of x makes this equation true? We have x over 3 equals 4. So just as we have spelled out the instructions, we said first of all, identify all the denominators. For the left-hand side, the denominator we have is 3. And for the right-hand side, the denominator we have is 1. We know there is no number under this, hence it can be over 1. If we have 3 and 1, what then is the LCM? So we know the LCM of 3 and 1 is equal to what? 3. So what you do is you multiply each and every term by this LCM. That simply means we multiply 3 by x over 3 and also multiply this term by 4. So that at the end of the day, this 3 cancels out to this 3, and then we are left with x. So we have x being equal to 3 times 4, which gives us a 12. That is all. And then we are done. Now, there are some books that are of the view that you can easily cross multiply. That is true, as I'll be doing for you to see. So we have x over 3 equals 4. And we know it's over 1. So we cross multiply. So that we have x times 1 giving us our x, then 3 times 4, which then gives us the 12. That is also very simple. But this is limited to when you have just one term at the left-hand side and then one term on the right-hand side as well. Take note, you can only do this direct cross multiplication if you have one term on the left-hand side and one term also on the right-hand side. But if that isn't the case, you cannot. Hence, I would always advise you use this. Stick to this, which says anytime you have a fraction, look for your LCM, multiply each and every term by the LCM, and then you are good to go. So let's take some few more examples. In this example, it says we have to solve for x over 4 plus 3 equals 7. So how do we go about it? Take note of the denominators. We have 4, that is the denominator of x. We have 1, that is the denominator of 3, and we also have 1, that is the denominator of 7. So 4, 1, and then 1. And the LCM of 4, 1, and 1 is 4. So we are going to multiply each and every term by this denominator. So that we have 4 multiplying x over 4. That is for the first term. Then plus, we have 4 multiplying 3. That is for the second term here. And then we have 4 also multiplying 7. Doing our necessary cancellation, we have x cancelling this. We have 4 taking out the 4. And hence, we will left with x times 1. So x times 1 gives us an x, then plus 4 times 3 gives us a 12. And we say it's equal to 4 times 7, which gives us a 28. With that, you realize that the whole equation has become a very, very simple linear equation. Making our x the subject, you have x being equal to the 28, then positive 12 goes to the other side to give us a negative 12. 28 minus 12 then gives us a 16. And that becomes the solution to our question. So you took note that it was just one term that had the denominator. Let's solve some examples where more than one term would actually have the denominator. So for this example, it says solve for x if x over 2 plus x over 3 equals 10. So we have x over 2 and plus x over 3 being equal to 10. Take note of our denominators. There is 2 and then there is also 3. So the first thing we need to do is to look for the LCM of 2 and 3. And what is the LCM of 2 of? And what is the LCM of 2 and 3? That is 6. So you put our 6 down. After identifying our LCM, we now go forward to multiply each and every term by this LCM. So what that means is we are going to multiply x over 2 by the 6. So we say 6 times x over 2. Then for this term, to multiply it by the LCM. So 6 times x over 3. Then we also multiply this term by the LCM. So 6 times 10. So with that done, we then do our necessary cancellation. And by that, we say 2 divides itself once, and it divides 6 twice. 3 divides itself once, and it divides 6 twice. We are done with all our cancellations. So we have 3 times x, giving us 3x. And then 2 also times x, giving us a 2x. And then that is equal to a 60. 3x plus 2x gives us a 5x. So you say 5x equals 60. And hence, if we want our x, we are supposed to divide both sides by 5. So 5 cancels out the 5. And we have our x being equal to 60 over 5. And 60 over 5 gives us an 8. So that becomes our answer. And we say, therefore, the x equals what? 8. You see how this was? All the denominators, at least more than one of the terms involved were fractions. So you consider all the denominators and find their LCM. Now, there are cases where in the numerator, you'd have an expression rather than just one term. Let's look at how we can deal with such examples as well. So let's consider this example we have here. It says 2x minus 1 over 4 equals x plus 2 all over 3. How do we evaluate this? You don't panic when you see such questions. It is just a build-up of all that we have done. So just take note of the steps and then what you are to do in each case. Hence, as we have always done, if there is a denominator, we look for the LCM. So the LCM of 4 and then 3 in this case is 12. So now that we have our LCM, we have to multiply each and every term by the LCM. So we multiply the left-hand side by the LCM, and we also multiply the right-hand side also by the LCM. So now say 4 divides itself once, and it divides 12 twice. 3 divides itself once, and it also divides 12 4 times. Now this is where most students start making mistakes. The 3 you have here does not multiply just the 2x. Neither does this 4 only multiply just the x. It multiplies everything you have here in the numerator. The same way 4 multiplies everything you have here in the numerator. So that simply means you have to rewrite it so that you have your 3 into bracket 2x minus 1. Then for the right hand side, we have our 4 into bracket x plus 2. Before we can now come and then simplify further. So that 3 multiplies 2x to give us our 6x. And it multiplies negative 1 to also give us a negative 3. 4 multiplies x to give us a 4x. And it multiplies 2 to give us an 8. We then have to make our x's the subject. So grouping like terms, we have our 6x, then minus 4x. That is 6x, which is already here. Then the 4x from our right-hand side comes to the left-hand side as a negative. Then on our right-hand side, we already have our 8. So we put our 8, and then negative 3 moves to the other side to become a positive 3. Simplifying further, we have 6x minus 4x, which gives us a 2x. So 2x equals 8 plus 3, which gives us 11. So making x the subject, we are then going to divide each and every term by 2. So that this 2 cancels out this 2. We are left with x, giving us an 11 over 2. So x is equal to 11 over 2, or a 5.5. Very, very simple. So this is how we solve equations involving fractions. You always need to eliminate your denominator, after which you realize you have any of the 3 we have already considered. Then you just follow the steps accordingly. As usual, I'll leave you with some exercises so you try your hands on them. So here are 4 questions just to test your understanding on all that we have done. And I do hope you'll be able to do them. If there's any issue of concern, you can always let me know at the comment section. Let's have Beyond Numbers, where we learn maths the easy way. If this is your first time and you think this channel will be of help to you, you can subscribe if you so do wish, so that anytime I release a video, you'll be notified as well. See you in our next lesson. Bye for now and stay safe.